Hello and welcome to my vvvv graphics tutorial. In today's tutorial we're gonna learn how to make something like this. So this is a 3D scan model that I took on my phone. So the base model looks like this. So this is the 3D model. We're also going to learn how to use this roughness and metallic texture to visualize like this 3D scan model inside vvvv, and later on we're going to convert that to a particle so that we can achieve a graphic like this. So this is shoes, not a shoes, sandal. Yeah, a wooden sandal that we used to use in Japan. So I 3D scanned that on using my phone, and then I read that inside vvvv, converted to a poster, and added some noise animation. So yeah, let's get started. Okay, so we're gonna start everything from scratch today. So I've got the scene window, I've got the stride opened, and then I've got scene window, root scene, and skybox, like just to make sure that you see the renderer. So I'm not using lighting, I guess, today. Maybe I am, but not sure. Yeah, let's get started. So I also need fuse to be open, so I'll use fuse. And then I need buffer. Wait a second, I always forget how this particle system works. So just go to the help browser, and this is like the usual case, I can't remember everything, so I just go to all these help patch to see what I actually need to do what I want to do. I'll look for the imposter. So today I'll use the imposter, so I'll be using the lighting as well. So then you get this as a help patch. So I want to render the imposter, sphere imposter, which means that we need a buffer to render it, buffer to entity, not the buffer to render entity, and also the structure buffer resource. So just copy and paste the structure buffer resource, and also I'll just copy paste these. Yep. Then yeah, I don't need anything else anymore, so I just go back here, get these buffer to entity connected, and zoom out, get all this up there, and then sphere imposter is here. But right now, yeah, I'll just get my, not really, I don't need these. I'll use the color, maybe color particle to this emissive rather than the age over lifetime. I don't need this for now. And is alive, I don't need it. Position, yes. Size, yeah, let's see what happens. Yeah, so this is the basic setup for the renderer, but right now I haven't connected anything as a particle system. So, and if you don't understand about the particle system, just go back to my previous tutorial. It explains what the basic setup and how to use it. And once we have this connected, yeah, structure buffer resource should be able to connect to the buffer to render the entity. So this is like the connection, like, so this one is the element count, so this shows the particle, maximum particle count, and this is the name of the particle. Today I'll just name it, how should I name it? Yeah, I'll just keep it as a particle. Too lazy to name something new. So now we're gonna start building the particle system. So that for that we need a compute system, and we also need a compute stage, I guess. Yeah, so these two can be connected like this, and then on this compute stage, as I explained last time, there's an emission stage and simulation stage, but we're going to be using this compute stage. And then I want to connect the structured bus for resource here, and to do so I need to go into configure and check this show resource to make sure that structure buffer resource can be connected to this compute stage. So after that, what I have to do is I just basically have to set up the particles. And to do so, for the last tutorial, I used this node called set. And to this, I connected this node called position particle, so that you could set this GPU void into compute stage and keep adding another one and another one for color and for whatever else aside, for example, that you use. But for today, I'm going to be using a more like simple node that's called set common attribute. So this is a node that already has this velocity, position, and size, and color, lifetime, and all these variables that you already need to set up basic stuff on particles. So I did this manually using set last time, but if you don't really I mean, I use this quite often, but it's also good to make sure that you know what was happening. So today we're going to be using this. So I set this set common attribute, and then I'll, just in case, I'll add this node called sphere random, just to make sure that we're getting all this particle system working fine. And this radius and default is 0, so I just set it to 1. And I'm not seeing anything, and this compute stage is blue. So I'll press F9 on keyboard to reset everything, and boom, now we see this particle working. I don't need a background for the skybox light anymore, so I'll just go back to the skybox light, left click, middle click, and toggle, and then I'll enable background. And it's moving too much, so I'll just turn on constant. Yeah, so now we've got a random sphere. This is something we did already for the last tutorial. So today I want to add I want to convert this to like a point cloud kind of visual using a 3D model file that I already have. So I'll put the link below, but if you go to my Sketchfab account, I have a model that's like this. So this is a 3D model that I have on my no, this is not mine. Models. So if you go to Sketchfab, I'll put the link below. I've got several like 3D scanned models that I can already do. If you have your own 3D model that's 3D scan on your smartphone and anything, just use those, because right now it's pretty easy to 3D scan your surrounding. For example, we have Luma AI, which is a great app that you can use on smartphone to 3D scan stuff. There's Polycam, and there's a lot of really cool software that you can use on phone or whatever. So if you have a smartphone with you, just try scanning something for your own and export it as an FBX or OBJ. I think OBJ is a bit easier for us to use for today, but yeah, if you have your own FBX or OBJ 3D scan stuff, just use those. If you don't have one, please just use one of these that I have it on my Sketchfab if you have an account. I think I'll use one of these shoes or whatever. Yeah, I'll use this one. Just get that. And if you go to this download 3D model, you should be able to download it as a OBJ file. So I already have this on my own local PC, but just in case I wanted to explain. So I have one on my own right here. So it's in the folder. I have this Gita thing, and the format is on OBJ, and I also have this diffuse texture. So I'll use this OBJ and diffuse texture to make sure that it's being rendered correctly. So I first need a file model, and then in this path, I'll just copy and paste this path from here, and then right click, and then I have this Gita.obj, and if you middle click this one, you should be able to see, but right now I'm not seeing anything. Seems like it's already loaded. So the problem is that it's a bit too big, and this happens quite a lot. If you don't see it, just make sure that you change the import scale on file model, and you should be able to see it. So next up, just to preview this, I'll use a node called model entity to connect this model into the entity, and then I'll connect this one to the root scene. So I add another one on root scene, and then model entity, and yes, now I see this guy is right here. I'd like to rotate a bit, but I'll do that later. Yeah, so I'll turn off the particle for now, because yep. So now I have this one. I'll add a PBR material, and then I'll add this one to the model entity, and then as I showed you, I have this diffuse color, and I have metallic and normal and roughness. So I'll just try connecting those to see if they all look good. So oh yeah, so I add a, I forgot how to connect these to nodes, so I'll just go to file texture value map. So I need a value map and file texture grayscale. Okay, let's try using these. So add a file texture. Yeah, there is a file texture grayscale. So I'll use this one, and then again copy this directory, and then I'll open up roughness. So this roughness should be fine, and then I'll connect this one to, oh, doesn't work. So this one is using the PBR. Oh, sorry. So we need to use the PBR material metallic. So I'll use this one, and then now you should be able to connect this to the roughness. So first of all, this is our roughness. I'll also need a diffuse color. So I need a node called color map, and I think, yeah, this one allows me to connect this to the diffuse. And then I'll add the file texture, and I'll just copy paste this directory, and then read the get a diffuse. So now I've got this 3D model that has the roughness and diffuse color. I also add a metallic just in case. I don't think it has anything to do, but I'll just connect this one. Metallic. Then last is I want to use the normal as well. So it has a normal input, and there should be a node, so you can't really connect anything to the normal. So I'll add a normal material. Nope. Where is the normal? So there should be a node. Material surface feature. Normal. It's not this. Oh yeah, it's this one. Okay. So I've got this one, and then the normal map is at vector 4. So I think I need the color map. Yep. And now I need the texture, and I'll read the same one, and I'll get the normal. Okay, so now we've got the normal and everything. So as you can see, now it's a pretty nice 3D model that has normal and roughness and all working fine. Yeah, so yeah, this one was just there to preview, so it doesn't have anything to do. But so what we want to do is we want to convert this to a particle. So first what I want to do is I need to convert this model, not convert, but I need to get the mesh out of this model. So mesh, I think it was mesh split. No. There should be a node mesh model, and then let's try find out a node that, oh yeah, get meshes. So there's a node called get meshes. With this one you can get a model input, and then you can get the first mesh and the second mesh and things like that. If you have multiple, then just use the get slice or something to get multiple out. We only have one right now, so I'll be using this first mesh. And then mesh, there is a node called mesh split, and for today I want to use the UV of the, later on I'm going to be using the UV of this model as well. So let's use the mesh split with UV here. So it should be the third one or the second one. So this, now it outputs the mesh position, the normals, the UVs, and the indices, and the primitive type. I only need a UV and the position for this one, but yeah, it's all good. So we've got this one. Now I want to convert this position to something that Fuse, this particle shader node, can read. And to do so, first node we need is dynamic buffer. So this converts this position to a dynamic buffer. And then I need a node called get item. No. Buffer in. Yeah, so there is a node called buffer in. And then there is a node called get item. Oh, and there's a get item buffer, I guess. So we can connect this one. And then there is a node called mod. Yep. And indexed. Okay, so I'm starting to forget what I need. So yeah, this is a setup that I mean I personally don't really know how this kind of logic works. I'm not familiar with this word. I get lost quite often. But in that case, what I usually do is I just go to the help browser again, and I remember, so I've been checking this help browser quite a lot, so I know where what is. So today I'm gonna read the help patch called external buffer. So there is the Fuse in particle category, there's one called use external buffer. If I open this one up, it shows me how to use this random spread into this particle system. So it's using exactly the same set common attribute, and then it's using this. Yeah, so this is the node I was forgetting. Dispatch thread IDX. So this is a node that I need. So I'll just get these ones, copy and paste. I'll delete this help patch, make this one slightly higher. Yep, so it's using the same get item. Yeah, this is the buffer one. I'm using the mod, so I'm missing this one. And then I think, oh yeah, let's just do how the help patch was showing. So then I need to count, and I need to make sure that this mod knows how many particles I want to show. So then I should be able to connect this get item into this set common attribute. So right now I'm not seeing anything, and that's because this buffer to entity is disabled. So once I enable it, and I'll just disable this model entity one. So now I see, as you can see, now we've got these particles. I mean, this 3D scan mesh as a particle here. Yeah, this was pretty fast. So if you want to get the other datas like normals and UVs, you can use exactly the same. And also this mod specifies the amount of particles that you want to draw. But I mean, if they're just static or you just really don't need to specify, you can also just connect this patch threaded ID. Then you should also be able to make the patch simple and then get the same result. I also want to rotate this, because I don't like how it's been. So I'll look for fuse and then rotate. And I'm not sure if it's rotate Y or Z or X. So I'll just rotate this one and 0.25. So this is the wrong direction. Rotate, maybe it's Y. Nope, then it's X. Yeah, so yeah, now I'm getting close. Yeah, so now, yeah, so minus 0.25. And now, yeah, I've got the coordinate correct. So this is the first step. So next up, I want to add the color to it. And to do so, I need to add a color to this system. So I've got the texture. So this is the texture that I want to know, but I need to specify the UV of this object and then apply these colors into the particle system. And this is something that I always forget and I still can't remember, so I'm gonna look for the help patch again. So if you go scroll all the way down, there is a help patch called, it's not a help patch actually, there was a really nice workshop material from this loop tool. So if you haven't got this, go to the nugget.org and loop tool. Yeah, and it's this one. So it's released by Gigantic. I think he gave a workshop on Node Institute recently, and he also released this sample patch. And there's tons of there's a lot of interesting help patch using Fuse, and you can learn a lot from it. So I would highly suggest downloading these and try to look for how it works. Yeah, so in this patch, in this help patch, there's this thing called mesh emitter. And if you open this one up, I mean, the loop tool is about this UI that he created, and this is really cool, but we're not using this today. If you go all the way, wait a second, all the way down to this. So what this help patch is actually doing is that, oh wait, yeah, it's on my second submonitor. So this is the visual that he's creating. And as you can see, he should be reading a 3D model, but the colors and the things are from the mesh that he loaded. And I was like, how do you actually get the color out of him? And I realized that he was using this file texture in. So texture in converts it to texture input, and then it samples the texture 2D, and then it converts the shader node vector 4, which is the color. So I realized, okay, this is how you do it, and what we see sampling for the texture coordinate. And then I went all the way up, and I realized he was using this UV data that comes from the model split to buffer. So if you open this one up, you can see that UV goes all the way here, and then he's doing something, and then he gets this UV out. So what I want to do today is I'm going to copy and paste this, the way he sampled the texture out of this, and then we have this one already. So I'll connect, or I'll just reconnect this one here to make sure that I'm getting the same texture output. Yep, so this is the same. And then I need to connect this one to the color, but right now I'm not seeing anything, and that's because I haven't got the texture coordinate here. So I need to get the texture UV coordinate from this mesh split, and to do so I'll use exactly the same setup as I did for the position, and then I'll connect the UVs to the get item dynamic buffer, and then I don't need to rotate, or do I? I'm not sure. Let's just disconnect this one, and then I'll put the get item to sample texture 2D. Yep, now we've got it. So now we're seeing, so we didn't need to rotate, so it didn't really matter. Dispatch it threaded ID could be copied, or we can reuse the same one. So now we've got the color. Right now the scale is a bit too small, so we can make it a little bit bigger. So now you can see it's all pretty cool. We've got a point cloud of our 3D scan model in vvvv. Maybe I don't need to rotate. Yeah, I should rotate this. Yeah, so this is the way to visualize like a point cloud visuals inside vvvv using this 3D scan model and this file texture 3D sample texture. So using Fuse. So yeah, this was what I wanted to share today. So this is the technique. After all, you can play around quite a lot. So after this, I'll just keep playing around to see if I can figure out an interesting visual. So if you just wanted to know how to make convert a 3D model to a point cloud, and this is the way. Rest of all, let's just keep playing. Okay, so I'm gonna add a noise to add some sort of like size animation. So right now the size is all static, so I want to add size is float 32, domains a vector 3, so I add it like this, and maybe I should make it, yeah, so the size is too big right now, so I'll just make this one 0.05 just in case if I add feed 1 here it's still okay. And then I'll add frequency. Yep, this is already pretty nice. And I'll add turbulence here. Yep, good. And then I'll lower down the amplitude, or maybe I should just keep it like this. And then I'll add an integrator so that I can animate these particles. 0.01. So now the particles are animating, looking pretty interesting already. This one is turbulence, but I don't need any right now. Let's change the gradient type, noise type, to something like sine. Yeah, this is maybe better. So the particles are now moving. It's pretty interesting. It's already quite nice. So you can play around. You can also add some sort of like, let's move around the vertices as well based on noise. So we can add multiply, and we'll add +1 here so that it doesn't get deformed too much. And then add this one and to the position. Yeah, so now it got distorted based on the noise, and so yeah, the shape is changing based on the noise. Is it? Wait, yes. Interesting. So, oh yeah, it's working fine. Yeah, I thought something was wrong, but it was okay. Yeah, so you can play around with the scale and everything. Yeah, but I don't like the shape to be distorted too much, and maybe I should use something different for the, yeah, I'll just keep this one connected here, then let it animate. Yeah, I think this is quite enough for what I wanted to do. I mean, I thought I could play a bit more, but oh, and by the way, this importer thing is a mesh of spheres. So what you can do is you can actually add some sort of like directional light, for example, and then it gives you this shadow and everything. So you can set up the lighting for this imposter So for example, if we add a directional light and then the skybox light without the background. So as you can see now, it got the lighting. So the lighting comes from the right side, I guess. Yeah. And then it's lighting up these particles. You can also add ambient. No, you can also add a point light. Let's set a point light to the center. Intensity and position. Let's set the position to 0, 0, 0, and then you can make the intensity up and down. So you can light up these every single particles to get these shadows and everything. I'm not going to be using this point light for now. So since imposters, sphere imposter have a material, there's tons of parameters that you can play around, like metalness and roughness. So you can also change the roughness to 1 and metalness as well. So if you want to make it metallic, then you can make it metallic with all the reflection. It doesn't look really cool, so I'll just keep the roughness 1. Then make the particles a bit smaller, like the default parameter, and then make this one a little bit bigger. So now it has more dynamic shape moving. Is it? Maybe. Yeah, so this was it for today. Oh, last thing. So another thing. So last time I shared that there's a few different stages, and if I change this compute stage to emission stage, you can also change the particle, how the particles act. So emission stage. Oh, and to emission stage, you need to connect another one called probably emitter, or it could be an amount emitter. An amount emitter and probably emitter is different. So this one, you have to specify the amount of particle that you want it to have. Probably emitter is more like a rough amount of particle. So you want this, and else just let the system manage how they use the particle. So there's a probably emitter and then emission stage. There should be something that I need to connect. Let's check that. I forget this. There is. Oh yeah. So this one is not supposed to be connected here. So this is supposed to be connected, and on the emission stage we have a show resource node, and then we connect this one to the compute system, and then let's press F9, and then all the particles should be updated. I'll delete these sample patch that I reviewed. So now this one is an emitted particle rather than a compute stage. So it's not like a sort of like point cloud visualization. It's more, it has a lifetime. So set common attribute has a lifetime. So lifetime at the moment is set to 3. And now as you can see, the particles are disappearing. And if you maximize, if you higher up this particle structure buffer resource amount a bit more, because the probably emitter reads this and says, okay, how many particle it can generate in total. And if that amount is not above this, then it can't render everything. So yeah, making this higher makes it more particles. So once you have this connected, you can also use a simulation stage. I'm not covering simulation stage for now, but if you're interested, there's tons of help patch and there's help patches. So check those out and see if you can play around with it. Okay, so that was it for today. Thanks for watching. I'll see you next time.